So we're the U.S. Air Force Drone Detection Identification and Counter Systems. I'm Jack, and I'm an intelligence analysis major.
Bailey, computer science major. Matthew Boyce, co-fed engineering.
Anna Rose, nursing major.
So to set the stage, basically what we're looking to develop is a system that is able to, is stateside and is working actively. And basically you have a counter drone coming in, enemy drone, either surveying or bringing a payload with some kind of weapon on it into an area where there's U.S. Air Force personnel that are there temporarily, so the system is able to be brought to and fro from a Bearcat or another vehicle like that. And basically the system is able to detect the drone coming in, and then we will have a counter mechanism, which is going to be a counter drone, and it will be able to fly and get close enough to the enemy drone that they'll pick it up with a net. So three hypotheses we tested this week were, can we jam GPS in order to make it easier for our counter drone to take it out? And through interviews, we were able to see that this may work. We need to figure out a way to kind of really get it honed in and be to leave a smaller footprint. And then will arc sensing alone be enough, and how reliable is it? And they do work, but because of kind of frequency jumping and different things they can do with that, it may not be super reliable. And then how effectively can we bring down a drone, bring our drone close enough when it's automated? And well, we were talking to a couple people that have done dogfights with drones and things of that nature. It's very difficult for them to get very close. So when it's automated, how do we kind of move forward with that? So some of our big breakthroughs were we're going to use spider wire or graphene as our net that's being carried by our drone. And also might be some ways we can also electrify it. It may not be on the drone, so we're also looking into a static version. If we can put up a wall that would be around, that would kind of be deployed by different apparatus, which we'll get into. GPS jamming works, but can we really minimize it and hone it in on a very small area? Because even talking to people within our sponsors, some people are like, oh, it won't be a huge deal. Other people are saying, well, it might kind of annoy some people depending on what equipment they're using. And then RF sensing, going back to that again, is it's not entirely reliable, especially if they're able to kind of go comms off and continue to fly without using different channels.
So with our mission model canvas, as some of you might remember, our key activities and key resources needed to be kind of revamped. So what we did, we targeted them first to what we are currently doing, what our current activities and what our current resources are in the scope of this class to get the program done, or to get the project done, and then what we would need to do in the future to take this product to market. So just to go through those real quick, we've been discussing with tech experts. We've been doing our own research. In the future, we'll need funding, and we'll need to do testing and develop the prototype, which we can then demonstrate to sponsors and investors. Key resources are the constraints that have been provided to us by the Air Force Nuclear Weapons Center, the advice that we're receiving from sponsors and such, funding, and a facility where we could test and have oversight from some of those people. Additionally, we were able to provide metrics for our mission achievement. These are rough metrics that we're moving forward with for now. We're pretty confident that we can exceed those metrics of 4 miles and 200 yards. Pains and gains and jobs. Our pains for this week, most of these have only changed in wording. For example, our second pain, forewarning time to drone threat, and then the third one, too much manpower required for effective drone counteracting. These were pains that were already present, but we've kind of reworded them. Gains, again, same thing. It's mostly just wording. We want to counteract the drone before it reaches the target, and we want the solution to be automated so that the input is minimized. And in jobs, an additional job was added that the threats to the facility need to be deterred.
The minimum viable product for detection is we're currently still going with the radar and RF detection for finding the drones coming in, RF to confirm whether it is a drone and not just a hawk or an eagle flying in the area, and then GPS jamming the drone is still a possibility that we're looking into on how viable it is. Takedown is, as Jack talked earlier, is using spider wire or graphene net attached to a drone, or if possible, alternate system that we were told might be feasible today, which is basically attaching a giant net to two balloons. And Jack can talk more about that here in a minute. And then using internal navigations on counter drones. That way they can basically surround the enemy drone with the net and take it down.
So, yeah, something else we're looking into is some kind of invisible fence. So if we're able to detect the drone from a couple miles out as it's getting closer and it's getting maybe 500 yards out, say it's 300 feet above the ground, if we can detect that, have a graphene net basically attaches to two helium balloons, say it's coming 300 feet from the ground, launch that 500, 600 feet in the air, those two balloons go up, and they're up within a few seconds, and then it flies into the net. And then that would also be able to be electrified easier because you can have a couple of car batteries and then connect it to it, and then it would mess with the sensors as well, pretty much fry it when it hit the net.
And just moving forward, we just want to continue looking into the feasibility of drone-to-drone interception, spider wire, and like the effectiveness of it along the lines with graphene. And we want to look into GPS jamming. We were suggested to look into both American GPS and Russian GPS, and also lower power GPS jamming. And just in addition, when automated, how to address like the target and when it's being caught.
That's what we have.
All right, great job, guys. Feedback?
I just want to, just a couple of comments in terms of the delivery, okay? The way you deliver the content to the audience. Something to think about for the final presentation. We're going to invite external individuals who have no idea what you're doing prior. So I think one critical thing you want to be successful in is to capturing their attention at the beginning of the presentation and keep their attention for the rest of the presentation. And I think we are okay because right at the current stage, we're more interested as faculty team. We're more interested in knowing how you learn from the process. But for the presentation, as far as the delivery, you might want to consider using a more like a changing tone rather than a flat tone. That's one thing. Second of all, I think when Bailey, I'm sorry, yeah. When you were talking about the MVP, for a second, I think you lost your confidence right there. I think it was just if I'm your client, you're the beneficiaries, the ones you want to really, secure that buy-in, then that's not the right way to do it. You want to be confident in your MVP, in your team, and to convince us by how you deliver the content. Of course, the content is important, but the way to deliver it is no less important. So I think that's something you could think about for the final presentation. I think you did a great job making the progress, so just something to think about.
Thank you. Yes, sir.
Guys, I'm trying to storyboard the scenario in my head where you have a highly maneuverable object in the air that's going to get caught by this net that's going to be raised by helium balloons and the timeline of that, right? Like what length?
I think that's more of like I wanted to mention it because we're looking into that. Our MVP is still going to be the counter drone lockdown.
Okay.
Right. And that's why we pointed out that they'll be using inertial nav and onboard accelerometers because it can get very close.
Right.
But the reason we mentioned the dogfights is because that's with human interaction, but with it's automated, it might be a little more difficult. So that's why it just depends on how long the net's going to be. Yes, that's still our MVP. So I think going off of that, throwing that in there confuses a lot of people.
So you want to focus on the main one for the presentation and just echoing John, kind of like really giving us a kind of a visceral sense of how this would work. But we're going to be working on that with the final presentation, which we'll do later on.
Can you tell us a little bit about, not names, but who you spoke to this week and how that changed what you did this week?
Yeah, so we spoke to a couple people that were more on the technical side. I think something that really helped us was talking to a couple more people that worked with the Stanford team. One that's kind of started a company and one just kind of has helped out. I think that helped us with like kind of realizing that there might be a simpler way to do this than playing with the tech, because there's might get a lot of kickback from military on using certain things.
Okay.
And then just kind of material stuff.
Okay. I would love to feel that pivot, in the way you presented. So I'm glad to hear that. Thank you. I think we're done with feedback. Great job, guys. 1, 2, and 3.